Hi, I'm Ravi Kambhampati. Welcome to this talk on mastering network resilience and scalability through routing and switching fundamentals. In today's session, we will cover the fundamentals of routing and switching, key technologies, advanced concepts, and how these concepts are applied in industries. By the end of this session, you will have a clear understanding of how routing and switching work together to build a resilient network capable of scaling to meet modern needs. Now, let's look at the agenda, the table of contents that I would like to discuss on today's conference. First, we would like to discuss about the introduction to routing and switching. The second goes the layer 2 switching and its fundamentals. And the third one goes some of the key technologies that are used in switching. The fourth goes the routing fundamentals and core protocols. The fifth goes the comparison of routing protocols and list of different types of protocols that are used in widely across the industry. And then goes the synergy between the routing and switching. The next goes the advanced network design concepts that we would like to discuss on. The last but not the least is the industry applications to see where all of these protocols and switching are being widely used. And at the end, we would like to conclude based on the opinion that I have that I would like to share with you guys. All right. So let's begin with discussing about some introduction about routing and switching. So yeah, in this slide, basically, I would like to introduce two core concepts of routing and switching. Switching operates basically at layer 2 of the OSI model, which basically handles traffic within the local area network by using a MAC address. This basically ensures the data is transmitted efficiently between devices within the same network. On the other hand, the routing operates at layer 3 and connects different networks by using an IP addresses. This enables data transmission between separate networks or across vast. Together, routing and switching form the foundation of modern networks. Understanding these concepts is really crucial for incident management, where quick troubleshooting and scalability are often required. Now, let's look into some of the layer 2 switching fundamentals. To discuss in detail, let's dive a little bit deeper into layer 2 switching, which is essential for local area networks. Switching basically learns the MAC addresses, learns and uses the MAC addresses to direct traffic, ensuring efficient communication between the same network. We'll also discuss VLANs, which allows network segmentation. Instead of treating all devices in as one large group, VLANs basically break down into smaller logical groups, improving the performance and security. Next, we talk about the trunking. Trunking allows the traffic from multiple VLANs to travel over a single network link. This is significant. This is significant because it increases the efficiency and also boosts the network capability, especially in large area networks. Finally, we would like to discuss about the spanning tree protocol, which is one of the important protocols, which is also called as STP. Basically, prevents network loops in redundant technologies, ensuring the network doesn't experience any downtime due to repeated data flows. All right. So now let's look at some of the key technologies that are used in switching technologies. Here we explore some of the key technologies that are used in switching. The one important thing is, as we discussed before, the VLAN is nothing but virtual area network. As mentioned earlier, are critical are basically for network segmentation. They help reduce broadcast trumps, keeping network traffic localized. By grouping devices into VLANs, administrator can basically manage network traffic more efficiently and reduce unnecessary data broadcasts. Trunking is the next key technology. Trunking basically eliminates the need for additional cabling by allowing VLANs to use a single physical connection. This makes your network more efficient, especially when managing a number of VLANs. Each of these technologies basically play a vital role in making the network more scalable, efficient, and secure. Now, in this slide, let's talk more about routing. Until now, we were discussing about switching. And now let's switch our gears towards routing and understand its core protocols and its efficiency and need for its need to use these protocols. Routing, unlike switching, operates at layer 3 and it is concerned with direct data across different networks. So there are several key routing protocols which are used for serving different purposes. Let's talk about OSPF, which is the first protocol. Before we get into it, I would like to list the different protocols. I would like to give an high level overview. OSPF Open Shortest Path first. The next one is EIGRP, which is Enhanced Interior Gateway Protocol. The third one is BGP, which is a Border Gateway Protocol. The fourth one is nothing but MPLS, which is Multi Protocol Label Switching. In OSPF, is a widely used link state protocol, basically suitable for large, complex networks. It offers quick convergence and high scalability. In EIGRP is a Cisco proprietary protocol known for its speed and efficiency. BGP is a backbone of the internet. It manages routing between autonomous systems, allowing data to travel from one network to other network across the globe. In MPLS, it's a multi-protocol label switching. It isn't a routing protocol per se, but a technique which is used by the service providers to optimize network traffic. So these protocols are the heart of network routing, enabling data to travel quickly, securely, and efficiently across networks. So now let's do some comparison between the protocols that we just discussed now. Now in OSPF is basically ideal for large enterprise networks and service providers where it's for fast convergence and scalability, making it a top choice. In EIGRP, as I mentioned, it is designed for Cisco networks, offering quick convergence and efficient bandwidth usage. It's highly efficient in terms of computational resources. BGP powers the internet, allowing for the policy-based routing and managing connections across different networks. It's highly scalable, but requires careful configuration. MPLS is used in service provider networks to optimize traffic and offer VPN services. Understanding the strengths and weaknesses of each protocol helps network professionals choose the right one for its infrastructure. All right. So let's talk about the synergy between the routing and switching. Routing and switching aren't basically two different separate processes. They basically work in tandem to ensure smooth data transmission across networks. While switching handles traffic with the local area, routing connects different networks. Together, they allow seamless communication within and between LAN and WANs. This synergy is crucial for modern networking, whether you are working in a corporate environment or managing a large-scale data center. The combined power of routing and switching is what keeps everything running smoothly and efficiently. All right. Let's discuss in detail about some of the advanced network design concepts. Let's list out all the advanced concepts that I would like to discuss in detail. The first one being the route distribution, the next one being the quality of service, other one being the IPsec. So basically, by integrating this advanced technology, we can design networks that are more resilient, efficient, and secure. So what is route distribution? Route distribution basically allows different protocols to share information, ensuring seamless connectivity in diverse network environments. However, careful planning is required in order to avoid routing loops or inefficiencies. Next one being quality of service enables the prioritization of network traffic. Crucial services like voice and video can be given a higher priority over less important traffic, ensuring smooth operations for essential services. The next one being IPsec. The IPsec basically adds another layer of security by encrypting data at the network layer, especially used for virtual private networks. By integrating these advanced concepts, we can design networks that are more resilient, efficient, and secure. So now let's look at this slide on industry applications. We would like to discuss how these are used in real-world scenarios. In enterprise networks, routing and switching basically enable low latency, seamless business operations, whether it's finance, retail, or manufacturing. In telecommunications, advanced routing and switching technologies power 5G networks, ensuring high speed, reliable, and seamless connection. In cloud computing, basically relies on seamless connectivity between on-premise cloud services, and this is where routing and switching become very crucial for hybrid cloud models and SD-WANs. For IoT and edge computing allow efficient management of connected devices, reducing latency and ensuring fast data transmission at edge. These examples show how vital these technologies are driven in modern digital transformation. So to conclude, we had a detailed discussion about different topics that we were trying to touch base on the agenda today. To conclude, I would like to say routing and switching basically act as a backbone of modern networks. As we move into the future of technologies like 5G, IoT, AI driven networks, the role of routing and switching will continue to expand. Future trends such as software defined networking, network function virtualization, NFVs, and intent based networking, IBN will automate and optimize many network functions. As network professionals, it's crucial to play and to stay on top of these developments, to design, implement, and manage networks that are resilient, scalable, and secure. Thank you so much for being part of this, and thank you for joining me today as we explore routing and switching fundamentals and their crucial role in building scalable and resilient networks. Stay curious and always look out for advancement in these network technologies. If you have any questions or concerns, or if you like to deep dive into a specific area, please feel free to reach out to me. Thank you.